Then algebra is 10 marks, calculus 35, vector and 3D 14, linear programming 5, and probability 8 marks. Okay. Then these are the different chapters in every unit. For example, in the first unit, we have relation functions, inverse. Then in algebra, we have matrices, determinants. In the calculus, we have 5 chapters. And then we have a linear programming, vectors in 3D, and then the probability. Okay. So we will discuss this weightage later on, Risha. For will be 2 hours. Yes, for once the previous topics will be completed, which you have missed, then your regular class will be of 2 hours only. Okay. Okay. So we will start with the matrices. What is a matrix? Let me explain to you. Just give me a minute. Just wait. Okay, so please remember the matrix is represented like this. Okay, and here we write the numbers, for example, this. Okay, so this one, the horizontal, this one is said to constitute the row. This is row 1 and this is row 2. Similarly, this is column 1, this is column 2, and this is column 3. Okay, so the vertical line of elements are said to constitute the columns, and the horizontal line of elements, these are said to constitute the rows. So what happened in matrix? In matrix, we arrange the numbers in the rows and columns form. So these are 2 rows and these are 3 columns. Next, you have a term order in a matrix. Order is what? For example, in this one, Risha, how many rows are there?
3.
Rows are 2, 1
Oh,
and 2.
sorry, 2.
Okay, rows are 2. And how many columns are there?
3.
Columns are 3. So the order will be 2 by 3. Okay, first of all, we will write the row number of rows, then this sign, and then number of columns. So we will read this as 2 by 3. Okay. So I hope this is clear to everyone. So you can write this definition that what is a matrix? It is a set of mn numbers arranged in the rectangular array of m rows and n columns. Okay. Next, we have a mn matrix is usually written as like this one. Okay. Rifat, I guess you have already done this.
Yes, sir.
Okay, then Rifat, just let me explain this topic. Then we will start from the addition. We will not do the type of matrices today. Okay, so this is our first element. We will represent the first element A11 like this. So what this first one represent? This represent the first row, and second represent the column. So first means first row, second number means first column. So A11 means this element belongs to the first row and first column. So if you will see here, this is row 1. And if you will check here, this is column 1. Okay, column 1. So that's why A11 means first row and first column. A12 means first row and second column. A13 means first row and third column. Similarly, A21 means second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. Okay, so I hope this is clear to everyone. Fahad and Rishabh, please note down this. Then we will start the further topic.
Yes, sir, done.
Very good. Fahad, this is done.
Yes, sir, done.
Okay, very good. Now next one. In compact form, the above matrix can be represented like this. Matrix is always represented by the capital letter. Okay, so here we have a matrix. That's why we are representing it by a capital letter. And this is, we write the matrix in the compact form like this. What is Aij represent? First alphabet. I represent the number of row and J represent the number of column. So for example, if we will talk about this, then we can say I is 1, J is 2 here. Okay. Again, the same thing, these numbers are known as the elements of the matrix. Okay. Again, we have already discussed this, the horizontal line of elements are said to constitute the rows. So please note down this and confirm me, then we will start next talk. Everyone, please let me know if this is done.
Yes, sir. Done.
Okay, very good. Okay, Fahad, very good. Now next one. Next is the vertical line of elements are said to constitute columns. We have already discussed that if we have this matrix, for example, this one, 1, 2, 3, 4, 5, 6, these vertical line of elements, these are said to constitute the columns. Now next one. Order of a matrix, we have discussed that if a matrix have m rows and n columns, then it is called a matrix of order m by n. Okay, Fahad, can you tell me the order of this matrix? Fahad, can you tell me the order of this matrix? 2 rows, this one. 2 rows and 3 columns, so 2 by 3. If you will multiply the order, then we will get a 6. If you will count all the elements which are given here, then 1, 2, 3, 4, 5, 6. So this matrix have 6 elements. Okay. Now, the number of elements in a m by n matrix will be equal to mn. So if you need to find the number of elements in a matrix, just multiply the order. You will get the total number of elements. These are the some example of matrices. For example, this one. These are the some examples. So please note down this, everyone, confirm me, then we will start next topic.
Yes, sir.
Okay, good. First, this done. Okay, good. Next, we have this question. Construct a 3 by 4 matrix. So first, can you tell me how many rows are there in this matrix? Okay, total elements are 12. That's fine. But rows are 3, columns are 4. So 3 rows means like this: A11, A12, A13, and 4 columns. So that is A14. Next is A21, A22, A23, A24. Next is A31, A32, A33, and A34. Okay. So this is a perfect example of this matrix. Okay. This is a matrix. Now we need to find this A11. We need to find these elements. So this is the relation. Now A11 will be equal to what? The value of I will be 1 and j will be 1. So that will be 1 plus 1, which is 2. Similarly, the value of A12 will be 1 plus 2. This will be 3. Similarly, A13, this is equal to 1 plus 3. This is equal to 4. Next is A14 is equal to 1 plus 4. That is equal to 5. Next is A21 is equal to 2 plus 1, which is equal to 3. A22, which is equal to 2 plus 2, is equal to 4. A23, which is 5. A24 is equal to 6. A31 is equal to 4. A32 is equal to 5. A33 is equal to 6. And A34 is equal to 7. Okay, I hope everyone understood this. This is a very simple concept. So now you just need to mention all these elements here. So this is 2, 3, 4, 5. Next is 3, 4, 5, and 6. Next is 4, 5, 6, and 7. This is clear? Fahad, Risha.
Yes, sir.
Okay, very good. So if you wish, please note down this, then we will start the next topic. Okay, please let me know once it is done. Okay, Fahad, good.
Done.
Okay, very good. So I hope you understood the basics of matrices. Okay, then you can do. Okay, just tell me the second question. A matrix has 10 elements. What are the possible order it can have? Can you tell me what the order matrix have if the total number of elements are 10?
5 by 2,
Very good. 5 by 2,
2 by
1 by
5,
10
1 by 10. Very good. Can we say 10 by 1?
and 2 by
yeah,
5.
2 by 5. Very good. Okay, so these are the possible orders. So please note down this. Okay, I hope you all have completed this. Shall we move to next?
Yes, sir.
Okay, good. Fahad, this time?
yes sir,
Okay, okay, very good. So now the type of matrices we will do in the later on, okay, because Rifat has already completed this in the last class. Now the next topic is equality of matrices. Okay, when we will say that two matrices are equal, so there are two conditions for this. Two matrices A and B are equal. First is they are of same order. So that means their orders should be same. For example, if we have this matrix 1, 2, 3, 4, 5, 6. The order of this matrix is 2 row and 3 columns, so 2 by 3. This will be equal to another matrix which have the same order. So first condition is the order should be same. Second condition is each element of A is equal to the corresponding element of B, that is equal to Aij is equal to Bij. So what does this mean? I will write here, I will draw another matrix. Suppose we have one matrix here, 1, 2, 3, 4. This is equal to another matrix if they have the same order. So this is 2 by 2. This matrix is also 2 by 2. Now here we have a x, suppose y, 3 and 4. So two matrices are equal if they have the same order and their corresponding elements are equal. That means first element will be equal to first element, second will be equal to second one, third will be equal to third, fourth will be equal to fourth one. Okay. So I hope this is clear to everyone. Please note down this. Then we will start the question on the basis of this topic. Please let me know once it is done. Fahad, Rifat, and Risha, this is done.
Yes, sir.
yes
Okay,
sir,
good. Okay, Rifat, this is done. Okay, very good. Okay, so we will check a question. For example, we have a question like this. Here, the two matrices are equal because we have this sign of equality. We need to find the value of A, B, and C. So we know that when two matrices are equal, when their corresponding elements are equal. So first element will be equal to first one. So if we will try to solve this, then we will get what? X plus 3 is equal to first element here is 0. Okay, so you can solve this, you will get a value minus 3. This is clear to everyone?
yes sir,
Yes,
Okay,
sir.
okay. Rifat, this clear? Okay, very good. So please try to solve this question and share your answer. Okay. Everyone, please let me know once it is done. Okay, Risha, very good. So your answer is x is minus 3, y is minus 5, z is 2, and a is minus 2, b is 1, okay, and c is minus 1. Risha, please check the value of b. All the values are correct except b.
Yes, sir. Got it.
Okay. For 2y minus 7 is equal to 3y minus 2 is equal to minus 5. Why it is equal to minus 5? For we have this equation 2y minus 7, it is equal to 3y minus 2. Okay, so shift this here, 2y minus 3y is equal to minus 2 plus 7. Okay, so here we will get minus y is equal to 5, so y is equal to minus 5. Okay, for this clear? Okay, so you are telling me the final answer, minus 5. Okay, then it's correct. Okay. And Rifat, this is done. Okay, very good. Rifat getting the same answer. Okay, very good. Fahad, please confirm me once it is done so that we can start the next question. Next, you need to solve this one. B minus 3 is equal to 2b plus 4. B minus 3 is equal to 2b plus 4. So shift this 2b to the left side. So b minus 2b is equal to 4 plus 3. So this is minus b is equal to 7. So b is equal to minus 7. This clear, Fahad? Okay, very good, Fahad. Now next one. Okay, so we don't have so much time, okay? Because in the main batch, we have done each and every question in the class, but in this batch, it is not possible. So please note down this. This you need to solve in homework, okay? And these are the answers of this question. So please note down this. In case you have a doubt, then we will discuss the same question in the next class. But I know that this is a simple question. You can solve it. So please note down this, confirm me, then we will proceed to next topic.
Yes, sir.
Okay, good. Rifat and Fahad, this done. Shall we start next? Okay, Rifat, good. Fahad, this done. Fahad, shall we start next? Okay, great. Again, this question is also a homework. Okay, please note down this, and this is the answer. Okay, Fahad, good. Rifat and Rishabh, please confirm if this is done.
Yes, sir.
Okay, good. Rifat, this done. Very good. Okay, this is also homework. Okay. Please note down this. Okay, please, whenever you solve it, please match your answer. Okay.
Yes, sir.
Okay, great. So Fahad and Rifat, shall we move to next? Okay. Leave this question. Just give me a minute. This question came in CBSE 2012, so you can try to solve this. Okay. The questions are very simple, based on the same concept which we have done earlier. Okay. So note down this. This is also a homework.
Yes, sir.
Okay, good. Rifat and Fahd, shall we move to next? Okay, good. This question is from your NCERT exemplars. Okay. Please note on this. I'm sorry, but we don't have so much of time. Okay. That's why maximum questions you need to do in the homework. But if you have any doubt, then we can discuss this in the class. Okay, fine. Rifat and Risha, please
Yes, sir.
confirm.
Done.
Okay, Rifat, this time. Okay. Okay, please note down the answer also. A is 2 and B is 2. In case your answer is not matching with this one, then please discuss with me in the next class. Okay, so till tomorrow, please try to complete this. Okay, shall we start next? Okay, this is the new topic, addition of matrices. Okay, so suppose we have two matrices, A and B. Both have the same order. Okay, always remember we can add two matrices. Suppose we have first matrix this 1, 2, 3, 4. We can add this matrix into the another matrix. For example, this one, if they have the same order. Always remember two matrices can be added only if they have the same order. So if we are adding these two matrices, what we will do, they have the same order. We will add the first element of this with the first element of this. So 5, next is 6, 2, 8, 3, 1, 4, 7, 4, 11. Okay, so I hope this is clear to everyone. The same thing is written over here that A and B are two matrices, each of order m by n. Then there's some A plus B is a matrix of order m by n and is obtained by adding the corresponding elements of A and B. Okay, so if you need to add two matrices, just add their corresponding elements, but the condition is the order should be same. Okay, so please note down this and confirm me, then we will try a question on the basis of this topic. Okay, Fahd, good. Rifat and Risha, please confirm me if it is done.
Yes, sir.
Okay. Okay, Rifat, very good. Now, for example, this one, please find A plus B and tell me the answer. You can tell me the answer row wise. Okay. Anyone can tell me the answer? Good for true. Next. Eight. Good. Next. Very good. -4. Then -1. 9 and 2. Very good, Rifat. This is clear. This is correct. Okay. Okay. So this answer was given by Risha. Good. Rifat, you're also getting the same answer?
Yes.
Okay. Very good. Okay, Fad. So the last value is 2. So I hope everyone has done this. Now, next our topic is multiplication of a matrix by scalar. So what will happen if we have this matrix? Suppose we have 1, 2, 3, 4. A is equal to this, and we are multiplying the A with 3. Then what will happen? Each and every element will get multiplied with 3. So first element will become 3, second will become 6, this become 9, this become 12. This is clear? Fahad, Rifat, and Risha. Okay, good.
Yes, sir.
Okay,
Yes, sir.
very good. Okay, so the same thing is written over here. Let A be a m by n matrix, K be any number. Then the matrix is multiplied by multiplying every element of A by K. It's called the scalar multiple of A by K, denoted by Ka. So K is equal to this one. Okay, the same thing we have already discussed. So please note down this, confirm me. Then we will start the next topic.
Yes, sir.
Okay, great. Fahad and Rifat, this is done.
Yes, sir. Done.
Okay, Rifat, very good. Good for. Next is properties of scalar multiplication. First property, this K is a smaller one. Okay, this is a small K. So if K is multiplied with A plus B, there are two matrices A and B. There's a bracket. If you're multiplying this with K, then what will happen? K will get multiplied with individually with both the matrices, and these two can be added. Next is, suppose we have two scalar quantity K and L. If these two are getting added and getting multiplied with A, this will be equal to Ka plus Ia. Okay, so these are the general concept. There is nothing new in this. You must be aware about it. Okay, please note down this, confirm me, then we will proceed to next topic.
Yes, sir.
Okay, good. Fahad and Rifat this time. Scalar means, for example, a matrix is denoted by this one, 1, 2, 3, 4. So scalar means we are multiplying this complete, for example, with 2, with 3, with 4, like this. We are not multiplying a matrix with another matrix. Okay. Next is subtraction of matrices. The same thing which we have done in addition. The same thing is there in subtraction. So if there are two matrices, same order, this same thing. You can subtract two matrices if they have the same order. Okay, and it is denoted by A minus B. You know that subtraction is denoted by A minus B, and it is defined as how you will subtract it. Just write A plus minus B. So this is nothing new. I will, while solving any question, I will again explain to you that what is the subtraction of matrices. Okay, so please note down this. In any of the question, I will explain to you. Okay. Okay, very good. First, Rifat and Isha, please confirm.
Yes, sir.
Okay, good. Rifat, this time.
Mm.
Very good. Okay, so I will solve this question. Please check here. Here you have this matrix A is equal to 2, 3, minus 1, 1. Okay, we are multiplying this with 3, so we are getting 3A, which is equal to 6 minus 3, 9, and 3. Next, B is what? B is 2 minus 1, 3, 1. We need to multiply this with 2. So we get what? 4 minus 2, 6, and 2.
So B is 1472.
Okay, I'm sorry. So B is 1472. If we are multiplying this with 2, we will get a 2, 8, 14, and 4. Next, what we need to do, 3A minus 2B. Okay, so this is equal to what? What is 3A? 6 minus 3, 9 and 3 minus 2b. So 2b means 2, 8, 14, 4. This is equal to what? 6 minus 2 is 4, minus 3 minus 8 is minus 11, 9 minus 14 is minus 5, and 3 minus 4 is minus 1. So this is a simple multiplication. Sorry, this is a simple subtraction, which you already know. The same thing was written in the previous slide. We will do this directly. Whenever we need to subtract two matrices, we will just subtract the elements which are present in the matrix. Okay, this is clear, Rifat, Fahad, and Risha?
Yes, sir.
Yes.
Oh, very good. So please note down this, note down the answer. And Abdur, Maziha, and Shravya, we will wait for 2-3 minutes for other students. Okay, then we will start the relation and functions. Okay. And in the meantime, please revise all the functions. Today we need to solve the question. So please revise Abdur, Mazia, and Shravya the functions. First, you will have a viva of 2 minutes. Then we will start the questions. Shall we start next? Rifat, Risha, and Fahad? Okay, Fahad.
Yes, sir.
Okay. Rifat, shall we start next? Okay. Okay, then please note down this question. This is a homework. Okay, this is a very, very simple question. This is the answer. So even you can directly tell me the answer, but please note down this. You need to complete this on the homework. Based on the direct formula is sine square theta plus cos square theta. This is equal to 1. Okay, Fahad?
Yes, sir.
Okay, good. Rifat, this is done. Shall we proceed next? Okay, okay, very good. Okay, this question is also a homework. Let me check first of all total question. Okay. Please note down this question. This is also a homework. Okay. Okay, Rifat, very good. Fahad, Risha, this
Yes,
done?
sir.
Okay, very good. So tomorrow we will start the next topic, that is multiplication of matrices. Okay. I will ask the team to share the assignments with you. But in the meantime, please solve these questions which I have given you today, and then check the portal. In the portal, they will upload the assignments. Okay. And Risha, in this batch right now, we are doing the relation function, and hopefully today is the last class of that. So if you wish, then you can join from tomorrow, because we will start a new chapter from tomorrow. Okay.
Sir, what are we starting tomorrow?
That I need to discuss with all the students today. Okay. Maybe we will start inverse or differentiation.
Okay, sir.
Okay. So do you have basic idea about the relation and functions?
Yes, sir. I'm fine with relations and functions.
Okay, okay. Then you can continue in the same batch. Okay. We are right now we are doing the type of functions. So we will do today the question based on 1, 1 and onto functions. Okay.
Okay, sir.
Okay. So just give me a minute. Okay, so we will continue our last topic, that is the domain and range. Okay, but before that, I will take a vibe of 2 minutes. So who can tell me, Abdul? Abdul, will you please tell me what is a 1-1 function? Abdul, what is a 1-1 function? Function having one and only one image, or we can say different elements have different images. Okay. Next, Shravya. Shravya, can you tell me what is a onto function?
Yes, sir. Onto function.
Yes.
So the function is said to be an onto function if all the elements of set B has an image and some other element in set A.
Very good. All the elements in set B have their pre-images in set A.
Yes, sir.
Okay. Okay, very good. So now we will try to solve the questions based on 1-1 function. Okay. The same problem which you faced in relations, the same still exists for function, that how to represent your answer. Okay. So please check this first question carefully, because the same steps you need to use in all the different questions. If you understand this first question, then the same logic can you can apply in the other questions. So please check here. Here we need to first of all that the function is 1-1 or not. One thing, if you already know that the function is not 1-1, then you can just give a simple example. Okay. If you know that the function is not 1-1, then you can give an example. But if you need to prove that this is a 1-1 function, then you need to use the standard method. For example, here in the first one, please check this step. First thing is, let x1 comma x2 belongs to R. First of all, you will assume two values from this first set. Okay. Now the problem is both the sets are R. So examiner can get confused that we are talking about which set. So what we will write here? Domain. We know that the first set is the domain. So we will write let x1 comma x2 belongs to R, that is domain, such that fx1 is equal to fx2. Okay, such that fx1 is equal to fx2. So what does this mean? What is fx1? Who can tell me? Fahad, fx is this. Can you tell me what is fx1? Yes, Shravya.
So fx1 is x1 cube plus 2.
Very good. x1 cube plus 2. Everyone, please see here. In 11th also, class 11th, we have done such type of questions. For example, fx is equal to x cube. What is the value of f1? If fx is given, you need to find, for example, f1. Then in place of x, you will put this value. So you will get a 1. Similarly, if you need f2, then you can put this value, 2 cube. This is equal to 8. The same concept you can apply here. Fx1 is equal to x1 cube plus 2. Similarly, x2, what is fx2? x2 cube plus 2. So I hope this is clear to everyone. So what you need to do, just assume two values from the first set. Write fx1 is equal to fx2. You get this value. Now 2 will get cancelled out. Now you get x1 cube is equal to x2 cube. x2 cube. You need to take the cube root from on both sides. So you will get x1 is equal to x2. Now, if you have assumed fx1 is equal to fx2 and finally you are getting x1 is equal to x2, then you can say hence the function f R2R given by fx is equal to x cube plus 2 is 1 1. Okay, so I hope this is clear to everyone. So to prove that the function is 1 1, what you need to do, assume two values from the set, from the first set, that is domain. Always write this is a domain. Put fx1. Okay, I will tell you, Abdul. Put fx1 is equal to fx2. Try to solve this. Finally, if you are getting x1 is equal to x2, then we will say that the function is 1 1. If you are not getting x1 is equal to x2, for example, you are getting this value x1 is equal to plus minus x2, then the function is not 1 1. Now, what is the logic behind this? Please check here. We have understood this from the arrow diagram. Suppose we have this set A and this is set B. Here we have two values, x1, x2. Okay. Now fx1 will give you what? Fx1 will give you the value in B. Suppose you are getting fx1 is equal to A. So that means that A is present here. If you are writing fx2 is equal to B, that means B is present here. So fx1 is equal to A means x1 is associated with A. Fx2 is equal to B means x2 is associated with B. Now what we are saying here, we are saying that fx1 is equal to fx2. We are saying that A is equal to B. So in place of this B, we can just write A. We can associate this like this. There is no B here because in the question, please check here. At this step, we have written fx1 is equal to fx2. So that means A is equal to B. So we have just written here, we have erased that B because the two values are same. For just give me a minute. Okay, now we are saying fx1 is equal to fx2. So as per this as arrow diagram, the x1 and x2 have the same image. Okay, but finally we have proved that x1 is equal to also equal to x2. These two are also equal. If these two are not equal, then different element have the same image. So this is not on 1 1. That's why these two have the same image if these two are same. So we have written here x1 is equal to x2. That's why this is a 1 1 function. Okay. For why we have written this? Your question is why we write domain. Domain we have written because the first element, the x1 and x2, we need to select from the first set. Okay, that's why we have taken this one. Anyone have a doubt in this? Please let me know.
So
So
before
this,
proving x1 is equal to x2,
yes,
x1 cube is already x1 cube is equal to x2 cube.
yes. Will you please repeat the question, Shravya?
So before proving x1 is equal to x2, the value of x1 cube is equal to x2 cube. Right?
Yes. This is because of this equation. In the equation, we have x1 cube is equal to x2 cube. That's why we have written again x1 cube is equal to this. Then we have find out the cube root. That's why we are getting x1 is equal to x2.
Okay.
Okay. So one by one, please raise your hand if this is clear to everyone. If you understood the first question, then you can solve all. Okay, Shravya, very good. Abdur, Fahad, Mazia. Okay, Rishabh, very good. Abdur, this clear? Okay, Fahad, good. Okay, Mazia, Rifat, this clear? Okay, Rifat, very good. Mazia, please confirm if this is clear. Okay, Mazia, very good. So, very good. All of you, please note down this. Then we will try next question. So one more thing, as we have discussed, this is a very complicated chapter. That's why we have done most of the questions in the class only. Okay, but from the inverse, I will give you a lot of homework. So please complete the homework because we need to complete the syllabus on time. For the tough chapters, we will do maximum questions in the class, but for the easy simple chapters, you need to do the homework. Okay, okay. One more thing. Anyone have an exam in this month? Can we start? Please message me on the chat box. Okay. Is this possible to start continuity and differentiability after this chapter? After relation and function, is it okay if we will start the continuity? Okay, Shravya. Okay, Abdul. I got two reply. After relation and function, is it okay if we will start the continuity and differentiability? I just received two reply. Mazia, Rifat, Risha. Okay, Fahad. Mazia, Rifat, is it okay? Yeah, from it to learn matrices and derivatives. Matrices and determinants, Risha. Are you saying?
Yes, sir, my bad.
Oh, okay, okay, no worries. Okay, Risha. So in the backup classes, we will keep on doing the matrices and determinants. Okay. When you have your exams?
2 weeks.
2 weeks. Okay. Hopefully, we will complete the chapters. Okay. Can you tell me the date? Exact date?
29th.
20th. Okay, we will try our best to complete it. Okay. I'm talking about this regular batch. So in the regular batch, what I want to start the continuity and differentiability. So who is left? Rifat. Rifat and Mazia, will you please reply me on the chat box? Is it okay if tomorrow we will start continuity and differentiability? Okay, Rifat. Okay. Okay, so after continuity and differentiability, we will do the inverse trigonometric functions. Okay, so thank you so much. So today we will try to complete this chapter. Okay, so I hope everyone has completed this. Shall we start next? Shall we start the next question? Okay,
Yes,
so
sir.
okay, so I'm going to erase this. Okay. So I'm again repeating the same statement. If you already know that your function is not 1, then just give a simple example. There's no need to prove the complete question. Okay. We will take a second one. Second is, what is z in this case? Anyone can tell me? What is the z?
Integer.
Integer. Very good. So function is from z to z given by fx is equal to x squared plus 1. Okay. So first of all, please guess this. What is a 1, function? Suppose we have a set A here. So in this case, it is Z. And we have a set A here, again Z. So if we have two elements here which have the same image, then we will say that this is not a 1, function. So please analyze this, x squared plus 1. This is a 1 or not? Is there any element which have, is there any two elements which have the same image? Okay. Tell me this. What is the value of F3?
10.
This is 10. Okay. 3 square plus 1. This will give us 10. This is not x cube. Okay, this is x square. Next, please find the value of f minus 3. Tell me the answer.
10.
Again 10. Okay, so minus 3 square plus 1 is equal to 10. So 3 and minus 3 have the same image. 3 and minus 3 have the same image here. So this is 3, this is minus 3. This have the same image. So the function is not 1. So you can just write like this. 3 and minus 3, 3 and minus 3 have the same image, hence the given function, hence the given function is not 1, 1. Okay. Abdur, please analyze the function. Okay. Most of the time, this even function, x squared, x to the power 4, x to the power 6, these are not 1, 1 function, because the positive and the negative value have the same image. Okay. So whenever the question is given, and also please check here. Here, integer is given. That's why we have put 3 and minus 3. But if a natural number is given here, okay, anyone can tell me if we will, in place of integer, we will take a natural number, then this function will be 1, 1 or not. If a natural number is given here, then the function is 1, 1 or not. Yes, then it will be 1, 1. Okay, because we can't put the negative number here. So for the even functions, the function which have the even power, in those functions, okay, there are chances that the function is not a 1, 1, because the positive and negative number will have the same image. This is clear, Abdur?
Yes.
So everyone please note down this, confirm me, then we will start the next question. Everyone please raise your hand if this is done. For 3 and minus 3 are two different elements which have the same image. Okay, so two different elements have the same image, then it is not 1, 1. What is a 1, 1 function? Different elements have different image. Okay, Fahd? It should have different image, yes. But here we have a same image, so we will say that this is not a 1, 1 function. Okay, so I hope everyone has done this. Okay, so we are just going to start next question. Okay, question based on onto function. So we will take first question. This is the first one. Okay, now we will check that how we need to solve such type of question. So onto function is tricky, so please check all the steps carefully. First of all, we will check that what is a onto function. So we have two sets, A, and we have another set, B. If all the elements, this is A1, A2, A3, this is B1, B2, B3. If all the elements which are present in set B have their pre-images in set A, okay, this, and this. If all the elements which are there in set B have their pre-images in set A, then we will say that the function is onto. Okay, if all the elements present in set B have the pre-images in set A, then we will say that the function is onto. So that means if we need to prove onto, then we need to assume an element from the second set. So please check here. For 1, 1, we will assume the values from the first set. For onto, we will assume the value from the second set. So first of all, we will assume a value y. Let, please check the steps carefully. Let y belongs to R, second set. So what this second set is called? Codomain. Codomain such that, like, y belongs to our codomain such that fx is equal to y. Okay. So what is the first step? First, you need to assume a value from the second set. What is second set is called? Please write here codomain, because both the sets are same. So you might get confused. That's why always write this codomain such that fx is equal to y. Now, what is fx? Fx is x cube plus 2 is equal to y. Now, what you need to do, find this value of x in terms of y. So you need to write like this: x cube is equal to y minus 2, and then you need to write x is equal to y minus 2 to the power 1 by 3. This is clear to everyone? Please raise your hand. Everyone, please raise your hand. I know this is a tough question for you, but please do the practice. Okay. Up to this step, first, second, and third. Okay, Shravya, Abdul, Fahad, Mazia, Rifat, and Risha. This is clear? Okay, Rifat, good. Abdul, Fahad, Mazia, Risha, this is clear? Okay, Abdul, I will. Fahad, Mazia, this is clear? Okay, Risha, okay, Mazia. Fahad, this is clear? Okay, very good. Please check here. For onto function, what you need to do, you need to assume a value from the second set. So we will always take y. Let y belongs to R, that is from the second set. What is the second set? This is called the codomain. So always write codomain if the sets are different, such that fx is equal to y. So you need to put fx is equal to y. Then you need to write x cube. What is fx? This one. X cube plus 2 is equal to y. Then you need to write x cube is equal to y minus 2, 1 by 3. Okay. Now, the further part is very complicated, but before that, I need to discuss something. You all know what is a real number. Okay. Now tell me one thing. If we have this function fx is equal to 1 by x, so for what value of x this 1 by x will be a real? Anyone can tell me for what value of x this 1 by x will be real? In place of x, what value we will put so that you will get a real number? Okay, y minus 2. Okay, no. Okay, just tell me this one. Under root x. If in place of x we will put minus 4, then please tell me that this under root minus 4, this is a real number or not?
Complex number.
Very good, Shravya. This is a complex number. This is not a real number. So always remember that inside the root, if you have a negative sign, then this is not a real, this become a complex. Always remember, inside the root, if you have a negative number, then it will become a complex. That will not be a real number. One more thing, always write in the denominator, if you will get a 0. In denominator, if you will, yes. So in a denominator, if you will get a 0, then that will not be a real. So if I will ask you what number can you place in place of x so that this 1 by x will be real, so you will say to me that real number except 0. In the denominator, you never have a 0. So for real, please remember these 2 points, that inside the root, you never have a negative sign. In the denominator, you never have a 0. Okay, please remember this. I hope you have done this in the domain and range in class 11. Okay, okay, then again back to our question. Now, this is square root we have already discussed. Now, this is a cube root. So in cube root, you can put any value. In cube root, you can put any value. You will always get a real number. So please remember this statement. We will write like this: for all y belongs to R, which are codomain. Codomain. For all y belongs to R, that is codomain, y minus 2 to the power 1 by 3. Codomain is set B, yes. For all y belongs to R, y minus 2 to the power 1 by 3 belongs to R. Please check here. In place of this y, if you will put any real number, then this complete expression will always be a real number. So what we are saying, for all y belongs to R, that means in place of this y, if you are putting any value of y, then this complete expression will always belongs to the real number. So we will write this statement thus: for all y belongs to R, that is codomain, there exist x is equal to, this is what? This is actually x. There exists x is equal to y minus 2 to the power 1 by 3, which belongs to R, which are domain. Thus, for all y belongs to R, there exists x is equal to y minus 2 to the power 1 by 3 belongs to R domain, such that fx is equal to x cube plus 2 is equal to y. Hence the given function I will again explain this, okay? Hence the given function is onto. Okay, check here what is mean by this. Suppose we have this set A, we have this set B, this is A, this is B. Always remember the value of y will lie in the set B and the value of x lie in set A. So what we are saying in this step, we are saying that all y belongs to R. So that means all y which is present in this set B. This set B is actually is what in this question? R. So we are saying for all y belongs to R. So that means all the real number which are present in set B. For all the real number in set B, there exists an element x in set A. We are saying there exists an element x is equal to y minus 2 to the power 1 by 3 in set A. In set A means in the domain, such that which will fulfill this condition. Hence, the given function is onto. Now, please raise your hand. How many students have a doubt in this? This is a complicated topic. I already told you in the beginning of the chapter, this is the most difficult chapter. So please raise your hand who have a doubt. Okay, who have a doubt in this question? Okay, sure. We have Fahad. Abdur have a doubt in this? Mazia, Rifat, Risha, please raise your hand if you have a doubt in this one. Okay,
No
Mazia.
doubt.
No doubt, Risha, very good. Okay, Rifat, very good. So I guess most of the students have a doubt in this. We will again discuss this. Okay. First thing is, what is a onto function? Or what is onto? If all the elements which are present in set B have their pre-images in set A, we will say that the function is onto. What is onto? If all the elements which are present in set B have their pre-images in set A, then we will say that this is a onto function. Now, what we are doing in this question, always we need to assume a value y in the second set. So we have assumed let y belongs to R from the second set. Both the sets are same. That's why we need to mention this, that what is this R? This is a codomain. Such that fx is equal to y, this you need to put. What is fx? X cube plus 2 is equal to y. Then the next step is, just a minute. Now, the next step is you need to find the value of x in terms of y. Okay. You need to find the value of x in terms of y. So you have put this x cube plus 2 is equal to y. You need to put x is equal, you need to find the value of x in terms of y. So we get this value. Now you need to check that if you will put y from here, this complete expression will get the value which is present in set A. So the same thing we have written here. For all y belongs to our codomain, y minus 2 1 by 3 belongs to our domain. Okay. Thus, for all y belongs to our codomain, there exists a value x, which is equal to y minus 2 1 by 3, belongs to our domain such that fx is equal to this one. Hence, the given function is onto. So I will suggest to you that please remember this statement. In each and every question, you need to write the same statement. Okay, Shravya, I will reply to your question. Okay. So the most difficult point is how to represent your answer. Okay, so please remember these three statements, first, second, and third. The same statement can be utilized in different questions. Okay, so Shravya, this is a very good question that you are saying, how do we know that there exists a value? There exists a value y. Okay, so Shravya, I already told you just sometimes back that when when a function is not real number, sorry, when we will not get a real number, when inside the root we have a negative and in the denominator we have a 0. In that case, we will say that this is not real. Except this, in all the cases, the function will be real. So please check here. Here we do not have a square root or even power. Okay, we have the odd power, so that is fine. Nothing is there in the denominator. That's why you can put in place of y any real number. This complete expression, the complete expression y minus 2 to the power 1 by 3 will always give you the real number. Okay. Okay. So Abdur, good question. Why we are starting with y? Why not with x? Because Abdur, the onto definition is based on the second set b. Okay. The value of y we will assume from the second set b. What is the onto? We focus on set b. What is the onto function? No element in set B should have their there should not be any element in B which do not have its pre-image in set A. So for definition of onto, we have to use the set B. That's why we have assumed the value of y, because y always lie in set B, x always lie in set A. This is clear, Abdul?
Yes, sir.
Okay. Then again, I'm saying to you the same thing. If you know already that your function is not onto, then there's no need to write the complete steps. Just give an example. For example, you already know that in set B there exists an element which do not have its pre-image, then please write that answer. Okay, I will give you an example. First of all of you please note down this, raise your hand, then I will give you an example for false cases. Okay, Abdul, very good. All of you please raise your hand if this is done.
Sir,
Yes.
a function is not said to be an onto function only if there exists a negative number under root, right?
That depends what the sets are given here. Okay, here real numbers are given. So what we are expecting that here, if we are taking any y real number, then for which we will get a real number here. Okay, Shavya. So this depend on these two sets. Here the real number is given. That's why we have taken an example of a real number, that is inside the root there should not be negative fraction, there should not be, sorry, in the denominator there should not be any 0. In case they will change the set, I will give you an example, please don't get confused. For example, if we have this one, fx is equal to 1 by x. Okay, so Shavya, please tell me, in place of x, what you can put so that you will always get a real number?
Anything other than 0.
Very good. But if what will happen if I will give you natural number to natural number? So what does this mean? Here you will put the value a natural number and you should get a natural number. So in place of x, we can't put 2, 3, 4. Why? Because 1 by 2 you will get and 1 by 2 is not a natural number. Okay, please don't get confused right now. I will solve these types of questions also. Okay, so I've just given an example that this depend on the sets. We will solve these types of questions also. So I guess everyone has done this. Shall I erase this one? Okay, I'm going to erase this one. If anyone is left, please let me know. Okay, okay. I will then rub this one. Okay. Now, first question we have done. Now the second one. F R2 are given by x squared plus 2 for all x belongs to R. Okay. If in the question you can directly tell that this is onto or not, then well and good. If not, then please try to solve the complete question and we will get the answer. So we will check this. We will check in the direct way. We will then solve this by the same method. Here the first set is R. Here the second set is R. The function is from R to R. Function is fx is equal to x squared plus 2. So here you have infinite values. You have -1, you have -2, you have 0, 1, 2, 3. Similarly, here this is also a real number. You have infinite values, -1, -2, 0, 3, 6, 11. Okay. Now please check here. If you will put a -1, then what you will get 1 plus 2 is equal to 3. So -1 will be associated with 3. Please put here -2. What you will get 4 plus 2 6. So -2 will be associated with 6. Put 0. Okay, there's 2 also. Put 0. So f0 is what? 2. 0 will be associated with this. 1 will be again with 3. 2 will be with 6. 3 will be with 11. Now please check here. This function is x squared plus 2. So that all real numbers. Yes, for I can't write all the real numbers. Okay, I've just written some examples. So please check here. This is fx is equal to x squared plus 2. So in place of x, if you will put any negative or positive value, answer you will get always a positive number. So that means in the second set, if you have some negative number, then negative number do not have the pre-images in set A. Okay, please check this function. In place of x, you will put any value, positive or negative, you will always get a positive answer. So that means in the set B, if you have some negative number, then negative number do not have the pre-images in set A. So that means this is not onto function. Okay, so directly we can analyze like this. If in exam you are not able to analyze in case of onto function, then it's fine. Just put the same, just use the same method which I already explained to you. Okay, answer 2. Again, let y belongs to R. What is R? Codomain. Codomain. Okay, such that, again same language, such that fx is equal to y. What is fx? X squared plus 2 is equal to y. What does this mean? X is square is equal to y minus 2. What does this mean? X is equal to under root y minus 2. Now please check here, we get an under root. So please take care whenever you get an under root. Now, who can tell me? Abdur. Abdur, can you tell me, is there any value of y, any real number y, which you will put in this under root, then you will get a negative answer. Inside the root, you will have a negative.
Sir, 0.
Very good, 0. So you can write like this for, because we are not able to decide in the beginning of the question that this is onto or not. So we are doing in this way. Now we get under root. We know that in case of real number inside the root, there should not be any negative. So we can see that there are chances that this become imaginary. So we will give that example only. So we will write for y is equal to 0, x is equal to, for y is equal to 0, this under root 0 minus 2 is not real. Hence, hence y is equal to 0 do not have its pre-image. So the given function is not onto. It's not onto. Okay, so we have written y is equal to 0. We get under root 0 minus 2. We know that this is not a real. This is the imaginary. So we have written this under root 0 minus 2, it does not belongs to R. Hence, y is equal to 0 do not have its preimage. So that means in this set, if you have a 0, then this 0 do not have its preimage. We have already checked this case. You can't put any value x here for which you will get the 0. So 0 do not have its preimage. That's why the given function is not onto. So they are infinite values. In root, negative value doesn't came. For that means inside the root, if you have a negative value, then that become imaginary. Okay, that is not real. That's why we are saying if we have any value y for which the under root become negative, then that is not real. So that means for that value of y, you do not have any preimage. Okay, so please raise your hand, all of you who understood this. Okay, sure, we are good. Okay, Risha, good. Okay, Rifat, very good. Okay, Fahad, good. Mazia, this is clear? Yes, Abdul, you are correct. If you, very good, Mazia. Abdul, you are correct. You can give the same example also. You can say that for y is equal to -2 under root -2 does not belongs to R. Hence, the given function is not onto. So there are infinite example for this case. Okay. So this thing I already told you in the beginning of the question that these negative numbers do not have their preimages. Even 0 do not have its preimage. Negative number do not have its preimage. That's why this is not onto. So very good. Please note down this. I will give you just 1 minute for this one. Please note down this and then raise your hand. I will start the next question. All of you, please raise your hand. So pre-image means value should not be same. For pre-image means, suppose this is A and this is B. 1 is associated with 2. 2 is associated with 3. Then we will say 2 is the image of 1. 3 is the image of 2. Okay, 2 is the image of 1. 3 is the image of 2. What this one is called? One is called the pre-image of 2. Okay, 2, 3 are called the image and 1, 2 are called the pre-image. Clear for? Okay. So I hope everyone has done this. Okay, I'm going to start next question. I will erase this one. If anyone is left, then please let me know. Okay, I'm going to erase this part. Okay, third part. Now, what is the Z here?
Integer.
Integer, very good. Now we will check this. Again, we are not able to analyze this, that this is a 1, 1 or not. Again, we will use the same method. Let y belongs to R, sorry, not R. Let y belongs to Z. What is the Z? We are taking codomain. Such that fx is equal to y. So that means what? 3x plus 2 is equal to y. We will find the value of x in terms of y. So we will shift all the values to the right side. So we will get 3x is equal to y minus 2. Shift this 3. So we will get x is equal to y minus 2 by 3. Okay. Now check here. Now we will analyze this. What is our first set? First is integer. Integer means 1, 2, 3, negative, minus 1, 2, 3. Second is also integer. So is there any value of y which you will put here and the complete expression you will not get an integer? Anyone can tell me?
Sir, 2.
2, but 2 minus 2 is 0, 0 by 3 is 0. So that is an integer. Is there any value of y for which you will, the complete expression, you will not get an integer? This is a very simple question. Is there any value of y? Hmm? What is the integer? Okay, Shravya. Shravya, what is the integer?
Both positive and negative numbers.
Yeah, for example, minus 2, minus 3, minus 4. So Shravya, in place of y, can you put any number so that this complete expression will not get an integer? So fraction is not an integer. Is there any value of y?
No,
No. Okay, then Shravya put 0 here. What the value you will get? In place of y, put 0.
negative 2 by 3.
Minus 2 by 3. Minus 2 by 3 is an integer or not?
It is an integer.
No, it is not. Okay. Here,
Oh,
here.
okay, yeah, I got it.
Okay, okay. So everyone, I got it. Why you are getting confused? Please check here. Integers are minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay, these are not real numbers. Sorry, these are integers. Fraction is not an integer. 1 by 2, 1 by
Yes, sir.
5. Okay, these are not integer.
Sir, what if you put 4?
Sorry.
No, sir, 6.
Abdul, will you please repeat?
Sir, what if you put 6 in the place of y?
Yes. So we will try to find the values. Okay, if you will put 6, then you will get a 4 by 3. This is also not an integer. Okay, the fraction which are not divisible are not integer. This is not an integer. So 6 is also a very good example. Okay. So what you need to do, once you get the expression, try to analyze it. Think that is there any number which I will put in place of y and the complete expression will not be an integer? Yes, there are many values. So is it okay if you will give a simple example? So we can say for y is equal to 0, this 0 minus 2 by 3 do not belongs to R. Hence, 0 do not have 0 do not have its preimage. Sorry, why I have written R here. Z. And 0 do not have its preimage. Thus, the function is not on 2. This is clear to everyone. Please raise your hand. Okay. Okay, Fahd. Abdur, Mazia. Okay, sure, we are good. Abdur,
So we can
Mazia.
take any values for y.
Any value of y for which you are not getting an integer, because we need to prove that this is false. Okay. So is there anyone who have a doubt in this? No. So I guess we need to take a break of 5 minutes. Okay, because some students are doing the class from the 1.5 hour. We will take a break of 5 minutes, then we will continue. Okay, only 5 minutes. So please take a walk. Do not see
Sir,
your mobile
till when is
phones.
the
Yes.
class? Till when is the class?
I need one more hour, Abdur. Okay, because I need to complete this chapter today.
Okay, sir.
Okay, so please do not see your mobile phone. Take a walk, have a water, and we will continue this in 5 minutes. Okay. Thank you. Yes, Risha, if you wish, you can drop. Okay. And please join at the same time tomorrow. We will continue the matrices in that batch and the differentiation in this batch. Okay.
Yes, sir. Thank you.
Okay, you're welcome. Okay, so all of you, shall we continue the class? 5 minutes are over. Fahad, Mazia, Rifaj, Shravya, shall we continue the class? Okay, Shravya. Okay. Okay, then we will start the next question. Okay. Bijective function. So who can tell me? Rifat, can you tell me what is a bijective function? Leave this, we will do later on. Okay. So Rifat, can you tell me what is a bijective function? No. Mazia, what is a bijective function? Fahad, are you there?
Yes, sir.
Okay, so Fahad, can you tell me what is a bijective function?
One-to-one and on-to function.
Yeah, perfect. Okay, so one and onto function both are called the bijective function. Now we will try this question. So here we have the signum function. Okay, this is called a signum function. We need to show that this is neither one nor onto. So we will just give a simple example. Now here we have two sets. The first set is what? Real number. Second set is what? Real number. So if we need to show this is not 1, then we need to give an example. Okay, you need to give an example of two numbers for which you will get a same image. Okay, so this is R and this is R. Neither 1 nor onto. So can you give me any two number for which you are getting the same image? Anyone can tell me? Anyone can give me any two numbers for which we will get the same image? Shravya, can you tell me any two numbers? Okay, please analyze this function. What is meant by this? What they're saying, the function is from R to R. So the first set is R, second is also R. Next, it is real number. Okay, but check here what they're saying. If you will put any value which is greater than 0, then the answer will be 1. So that means what? If you will put 1, answer will be 1. If you will put 2, answer will be 1. If you will put 3, answer will be 1. So if you will put any value which is greater than 0 from here, then fx you will get a 1 only. What is mean by this? If you will put 0, then you will get a 0. It's okay. If you will put any value which is less than 0, you will get a -1. For example, if you're putting -2, f -2, you're putting f -3. If you're putting f -4, then you will get what? -1, -1, and -1. Okay. So what the example we can give? We can give the same example. We can say that the 1, 2, 3 have the same image 1, hence it is not 1, 1. This is clear to everyone. Fahad, Mazia, Rifat, Shravya, please raise your hand. This is clear. Okay, very good. Fahad, Mazia, Rifat, and Shravya. Okay, Fahad. Okay, Rifat. Okay, Shravya. Mazia, this is clear. Mazia, this is clear. Mazia, please reply me. Okay. So what we can write here? We can say only 2 examples are enough. We have taken 3 here, so we can write like this. 1, 2, and 3 have the same image. 1. Hence the given function. Is not 1, 1. Okay, so I hope this is clear to everyone. Please note down this, and for onto, please give me an example. Please analyze this function and give me an example for onto function. Okay. Abdur, you have just joined. We have started this question, so please check here, Abdur, and all of you, please note down this and give me an example for onto. So Abdur, this is a signum function. What is a signum function? This value. This value is called the signum function. You need to show that this is neither a 1, 1 nor onto. Okay, Abdur? You need to show that this is neither 1, 1 nor onto. So we will take example, Abdur. Abdur, what is mean by this x is greater than 0, value is 1? That means if you are putting any value which is greater than 0, the function will give you 1 only. So for example, if we will put 1, then the function will give us 1. If we will put 2, function will give us 1. If we will put 3, function will give us 1. So that means 1, 2, 3 have the same image 1. Hence the given function is 1, 1. This is clear, Abdul?
Yes, sir.
Very good. So please note down this, Abdul, and give me an example for onto. And this is from all of you. Please give me an example. And if you have any doubt, then please let me know. Everyone has done this. Now, any example for onto? Please check here. Please check here. So here we have a real number. Now, and here also we have a real number. For example, if we are putting a value 1, 2, 3, 4, and here we have suppose -2, -1, 0, 1, -1. Okay, -1 we have already -10. So if you are putting 1, you are getting 1. If you are putting 2, you are getting 1. If you are putting 3, you are getting 1. If you are putting 4, you are getting 1. So please check here. Here the answer you will get is always 1, 0, and -1. So that means the elements in set B except 1, 0, and -1 do not have the pre-images in set A. This clear? In set B, the elements except 0, 1, and -1 Except these three numbers, rest of the elements do not have their pre-images. That's why this is not on 2. This is clear to everyone. Fahad, Mazia, Rifat, Shravya. This is clear?
Yes.
Good. Fahad, Mazia, Rifat, this clear? Yes, I will. So I hope everyone has noted down this. Then I will erase this one. Please check here. So what I'm saying that in the first set you have the real number. In the second set you have the real number. Okay. Here you have infinite values, but the outcome you will always get 1, 0, and -1. For example, you have a -10 here. Answer you will get only these three values because it is given in the question that if you will put any value which is greater than 0, you will get a 1. You will put 0, you will get a 0. You put a less than 0, you will get a -1. Okay. So this means this is another one. This is not onto. So what the statement we will write? Values except, or we can say real number except -1, 0, and 1 in codomain do not, okay, are in bracket we will write real number, do not have their pre-image, do not have their pre-image, hence the given function, is not onto. Okay. Now please confirm me how many students have a doubt in this. Anyone have a doubt in this one?
Yes.
Okay. Fahad, Mazia, Rifat, this is clear. Fahad, Mazia, Rifat, this is clear. Okay, Rifat. Fahad and Mazia. Okay, Fahad. Mazia, this is clear.
Sir, can you explain once again?
Yes, Abdul. I will. Mazia, this is clear. Okay, Abdul, please check here. Here we need to prove that this is not onto. Okay, so when we will say that the function is not onto, when in second set B we have an element which do not have its pre-image. So if you will analyze this question, then whatever value you will put in place of x, the outcome will be only 1, 0, and -1. Okay, Abdul, you will always get a 1, 0, and -1. Whatever the value you will put here, the outcome will be 1, 0, and -1. So what we can say, please check here. In the second B, we have a real number and we have an infinite value here. But except 1, 0, and -1, rest of the element do not have the pre-image. That's why we will say that this is not onto. The same thing I've written here, that the real number except -1, 0, and 1 in codomain do not have the pre-image. Hence, the given function is not onto. This is clear, Abdul, now?
Yes, sir.
Okay, and 1, 1, Abdul, you have noted down the 1, 1?
No, sir, can you show it?
Yes, yes, I will again do that. Okay, so everyone please note that onto part. For 1, 1, what we will do, we will give an example. F1 is equal to what? 1. What is F2, Abdul?
So 1,
Again, good. What is F3?
1.
1. So we will write 1, 2, 3 have the same image, hence the given function, is not 1, 1. Okay, this clear, Abdul?
Yes, sir.
Okay, very good. Please note down this, all of you. Raise your hand. Once it is done, we will start the next question. Okay. Please, okay, Abdul. Fahad, Mazia, Rifat, and Shravya, please confirm. Okay, good Shavia. Fahad, Mazia, Rifat. Good Rifat. Fahad and Mazia. Then that would be one function, right? If it would be other image, yes, if they have different image. Okay, Fahad. So we need to analyze all the numbers. If every number have the different image, we will say that this is 1, 1. Then negative values, yes, for the same 1, 1, Abdul.
Yes, sir.
Okay, so for example, Abdul, take the f minus 10. What's the value of f minus 10?
So -1.
Good. Minus 9. What's the answer?
So -1.
Again minus 1. So we will write minus 10, minus 9 do not have the same image. So it is not 1, 1. Okay.
Yes, sir.
Okay. So I hope everyone has done this. Now we are going to start the next question. Okay. Now I will give you some homework. Okay. The easy question you can do in the homework. But okay, solve this question right now. I will give you 3 minutes for this. So please try to solve this question and confirm me if you have a doubt, then I will explain this to you. For Q means rational number. Okay. No, first, rational means the number which are in the form of P by Q and Q is not equal to 0. Okay. So all the decimal numbers are included here. All the fractions are included here. Rational means decimal will come. Okay. Okay, so I hope everyone has done this, and who have a doubt, then please check here. I will solve this. Same steps which we have performed in the previous questions. 1, 1. Okay, what we do in 1, 1? We assume two values from the first set. So let x1 comma x2 belongs to Q. What is Q? Domain. Okay, from the domain. Such that fx1 is equal to fx2. So that means 2x1 minus 3 is equal to 2x2 minus 3. Minus 3 will get cancelled out. So you will get 2x1 is equal to 2x2. And from this, you will get x1 is equal to x2. Okay. Next is onto function. Okay, so we will write hence the given function is 1, 1. Hence the given function is hence the given function is 1, 1. Okay. Now next one, onto function. Onto function, again same step. You need to assume a value from the second set. Let y belongs to Q. Which Q? Codomain. Such that fx is equal to y. So what is meant by this? 2x minus 3 is equal to y. Now find x in terms of y. So 2x is equal to y plus 3. So here we will get x is equal to y plus 3 by 2. Okay. Now, please analyze this one. If you will put any rational number in place of y, then will this complete one be a rational? Yes. Okay, so we will write in this way. For all y belongs to Q, y plus 3 by 2 belongs to Q. Thus, for all y belongs to Q, there exists, okay, which Q? This is domain. There exists, for all y belongs to Q, there exists x is equal to y plus 3 by 2 belongs to Q, okay, domain. Further, I will explain you in a minute. So for all y belongs to Q, there exists x is equal to y plus 3 belongs to Q codomain such that fx is equal to 2x minus 3 is equal to y. Hence the given function is onto. Okay. Now please check here. So what we are saying for all y belongs to Q. Q means this is the codomain. The y plus 3 by 2 should belongs to the domain. Okay, y domain. This is equal to what for x? This is equal to x, and x belongs to what? To the domain. This clear? Okay. So everyone please note down this. If anyone have a doubt, then please let me know. Okay, I will explain to you. Otherwise, we will start the next question. Okay. So everyone please raise your hands once it is done. Which example for? Will you please unmute yourself?
Yes, sir.
Yes. For example for which case?
So this one, x is equals to y plus 3 by 2.
Yes. So what I'm saying here, if you will put in place of y any rational number, for example, if you will put 2 here, what you will get? 2 plus 3 by 2 plus 3 by 2, which is equal to what? 5 by 2, which is a rational number. Okay, so we are saying this, that in place of y, if you will put any rational number, okay, then the final result will be a rational. So Abdul, what is your question? What if you put 0 for onto? Abdul, for in place of this, if you will put 0, you will get a 3 by 2, and 3 by 2 is a rational number. Okay, Abdul?
Sir, Q stands for rational, right?
Yes, Q stands for rational. Okay. So everyone, please do this. Raise your hand so that we can start the next question. Abdul, Fahad, Mazia, okay, Shravya, Fahad, Mazia, Rifat, please confirm if it is done. Okay, Rifat. Okay, Abdul, Fahad, and Mazia, this is done. Shall we start next?
Yes, sir, done.
Good, Fahad. Abdul and Mazia, shall we start next? Okay, Abdul, good. Okay, Mazia. Okay, so we will start next one. Then please note down this last statement. Okay, I'm not sure you have completed this. So please note down this, then we will start the next question. Okay, I'm going to start next question. Now, this show that there's a digestion. This we will do later on. Okay, these are quite difficult. Yes, this is a very simple question. So you need to show that this is 1 1 but not onto. Okay, please try this question. And if you have any doubt, then let me know. I will explain this to you. Okay, I hope everyone has done this. Whoever have a doubt, then please check here. We need to show that this is 1, 1, but not on 2. So for 1, 1, again same method. Let x1 comma x2 belongs to first set and what is the domain? Okay, such that fx1. Yes, if you have the example, then you can give, but okay. So this means 2x1 is equal to 2x2. So this implies x1 is equal to x2. Thus the given function is 1, 1. Next is onto. What we can do in case of onto? If directly you are not able to give an example, then please do in the same way. Let y belongs to n, that is a codomain. Okay, such that fx is equal to y. Then put fx. What is fx? 2x is equal to y. So that means x is equal to y by 2. Now, both the sets are natural numbers. So anyone can tell me any value of y which we will put here and we will not get a natural number. In this expression, can you give me any value of y which we will put here and we will not get a no. Anyone else? Any example in place of y so that the complete expression will not give us a natural number?
Sir, 3.
Shravya, we will put a natural number only. Okay, so 0 is not a natural number. And who told me 3? Abdul?
Sir, 3.
Very, very good. Very good. 3. So for y is equal to 3, x is equal to 3 by 2 does not belongs to the natural number. Okay, hence the given function is not onto. Hence the given function is not onto. So I hope everyone now understood this, that how you need to solve the question. Okay. So for onto, if you are not able to directly analyze the situation, analyze the question, then please do in this way. Okay. So I will just give you 1 minute for this. Please note down this and then raise your hand. Then we will try another question. Okay. So we will try to complete as many as questions today. So we have 16 questions, not 16, 15. So 10 are left. For 1 to 1, we equate the equation. For on to, we find for x. Yes, Abdul, that this is the concept. Okay. For 1 to 1, we need to assume x1, x2. For second one, we will assume y, and then we will find x in terms of y. And if you have an example, you already know the example, then just give an example and say that this is false. Okay.
So, sir, we follow this method in every question.
In every question. Yes. Okay. I hope everyone has done this. Shall we start next? Okay, sure. Good. If you put y is equal to 2, then answer. That's correct for. But for if we need to prove that something is false, then only one example is enough. We will give that example for which your equation is false. Okay. Even for 1,000 values, your answer is correct, but there lie a single value for which your answer is not correct, then just give that example. I hope everyone has done this. Now I will give you a homework. So this question is homework. We have already done this question. I guess this is the same one. Okay, leave this. Yes, this is a homework. Neither one
So
nor
question number 6 is not homework.
no, that was the same question, the same as 5. So leave that. Please note down this question number 7. This is a homework. Okay.
So,
We
so
have,
by same method we have to solve, right?
yes, the same method. Okay. We have already solved this type of questions. We have done a question where the value was fx is equal to x squared plus 1. So if you have any doubt, then you can check out that question. So please raise your hand once you will complete this. Okay, sure, we are good. Abdul Fahad, Mazia and Rifat, please raise your hand. Okay, Abdul Fahad, good. Good, Rifat. Very good, Mazia. We will check our next question. Okay, this is a very simple question. This is also homework. We have already done the same question before. Same type of question. So please note down this. Okay, and please complete these questions. Please raise your hand once you complete it. Once you note down this, then we will start next one. Okay, Fahad, good. Abdur, Mazia, Rifat, and Shavia. Please come. Okay, Shavia, good. Okay, Rifat. Okay, Mazia. Okay, very good. I hope everyone has done this. So I'm going to start. Next one. Okay. Okay. We will solve this question right now. Please try this question. Okay. What is R naught? R naught is real number except 0. Okay, so we need to show that this function defined as fx is equal to 1 by x is 1, 1 on 2, where R naught is set of all real number except 0. Okay, so please note down this, confirm, try this, and let me know if anyone have a doubt. Then I will solve this question. Okay, Shravya, then we will continue this topic tomorrow, okay? Okay, so everyone, please try to do this question, and we will solve this question tomorrow. Okay? Okay, you're welcome. Okay, Abdul, Fahad, Mazia, Rifat. Abdul, we will solve this question tomorrow. So please try to do this in homework. If
Yes, sir.
you have,
By same method.
yeah, by the same method. Okay, because some of the students are doing the class from the lab more than 2 hours. So, okay, then we will continue this tomorrow. Okay, Abdul, Fahad, Mazia, Rifat. Okay. Okay, then. Thank you so much. Please do the homework. Please do the homework for this one. Okay. Okay, then. I'm going to close the session. Okay. Thank you.